In this video, we will solve Chapter 2, H.C. Verma book, Chapter 2, Physics, Unsolved Numerical Problems. This is the first problem. A car move 100 meter due east direction and then 25 meter due west direction. What is the distance covered by the car? So, in the question, they are asking the distance covered by the car and the displacement. Distance is a scalar quantity. So if a car is moving 100 meter due east and 25 meter due west, then the total distance is just the sum of both the numbers. So 100 plus 25 is 125 meter. So distance covered by the car is 125 meter. And the displacement is a vector quantity. So if a car is moving 100 meter in east direction, then returning 25 meter in west direction, so the displacement is 100 minus 25, because we have to be very careful with the direction. So 75 meter due east is the answer for the displacement. In the second question, a person walks along the sides of a square field. Each side is 100 meter long. What is the maximum magnitude of displacement of the person in any time interval? So this is the square field. Each side is 100 meter long. So the maximum displacement for this will be the diagonal distance of the square field, that is AC. So the distance AC will be the maximum displacement, is equal to the maximum displacement, and we can calculate the distance AC by using Pythagoras theorem. 100 square plus 100 square is equal to AC square. So AC is 100 root 2. So 100 root 2 meter is the answer. In the third question, in the hare tortoise race, the hare ran for 2 minutes at a distance 7.5 km per hour and slept 56 minutes. Again run for the 2 minutes with the speed 7.5 km per hour. Average speed. We know the formula of average speed is total distance divided by total time covered. Total distance covered in a total time. So distance we can calculate with using the time and velocity. So velocity into time is equal to the distance. So 7.5 multiplied by 2 by 60. Again 7.5 multiplied by 2 divided by 60. And the total time is 2 minutes, 56 minutes and 2 minutes again. So 2 plus 56 plus 2 and we convert this minute into hour. So we divide this number 60. So the answer is 1 by 2 km per hour. So the average speed of the hare in this race is 1 by 2 km per hour. In the fourth question, a bus takes 8 hours to cover a distance of 320 km. So what is the average speed of the bus? Again, average speed is equal to total distance divided by total time. Total distance is 320 km and the total time is 8 hours. So 40 km per hour is the answer of this question. In the fifth question, the maximum speed of a train is 80 km per hour. It takes 10 hours to cover a distance of 400 km. Find the ratio of maximum speed to the average speed. So first we will calculate the average speed. Average speed is equal to total distance by total time. Total distance cover is 400 km and total time is 10 hours. So 40 km per hour is the average speed. And they want us to calculate the ratio of maximum speed to the average speed. Maximum speed given in this question is 80 divided by 40 and we will get the 2. 2 is a number because we are calculating the ratio. So 2 is the answer of this question. In the sixth question, an object moved through 10 meter in 2 minutes and next 10 meter in 3 minutes. Calculate the average speed. Average speed is total distance by total time. So total distance is 10 meter plus 10 meter and total time is 2 minute plus 3 minute. So 2 plus 3 is equal to 5 minute and total distance is 20. So when we solve this, we get 4 meter per minute is the answer of this question. In the 7th question, a car moved through 20 kilometer at speed of 40 km per hour and the next 20 km at a speed of 60 km per hour. Calculate the average speed. Average speed is equal to total distance by total time. Total distance is 20 km plus 20 km and total time is time we can calculate by distance by velocity. So d1 by v1 plus d2 by v2. So 40 divided by 20 by 40 and 20 by 60. When we will solve, we get 48 km per hour. So average speed of the car is 48 km per hour. A boy leaves his house at 9:30 a.m. for his school. The school is 2 km away. The class starts at 10 a.m. So he should reach the school by 10 a.m. If he walks at a speed of 3 km per hour for the first kilometer, and what speed should he walk for the second kilometer to reach just in time? So he start from 9:30 and he should reach by 10 o'clock, and the total distance is 2 kilometer, and the total time he is having is 30 minutes. So for the first kilometer, so starting 1 kilometer, the time used is distance by velocity. Distance is 1 kilometer and time is uh, distance by velocity. So 1 by 3 hour, that means he uses for the first 1 kilometer. Remaining time is 1 by 2 minus 1 by 3. 1 by 2 means half hour, 30 minutes, minus 1 by 3 is equal to 1 by 6 hour he is having for the next 1 kilometer. In this time, the boy should reach to the school. So velocity is equal to distance by time. Distance is 1 kilometer and time is 1 by 6 hour. So 6 kilometer per hour should be the speed for the last 1 kilometer. In the 9th question, a bus moved at a uniform speed v1 for some time, and then with a uniform speed v2. The distance time table is given in the below, and the corresponding distance time graph and the answer for the following question. So they are saying that a bus move at a uniform speed v1 for some time, and then uniform speed v2. So this is time and this is distance. So first we will calculate the velocities. So time here and distance here. We calculate the velocity by 20 minus 0 divided by 20 minus 0. So 1 kilometer per minute. Then again 40 minus 20 is equal to 1 kilometer per minute. Then 65 minus 40 divided by 60 minus 40 is equal to 25 by 20 kilometer per minute. Then 95 minus 65, 80 minus 60, so 30 by 20 kilometer per hour. Again 125 minus 95, 100 minus 80, 30 divided by 20 kilometer per hour, and 155 minus 125 and 120 minus 100 is equal to 30 by 20 kilometer per hour. So in this question they mentioned that for some time the uniform velocity, so 1 kilometer per minute and 1 kilometer per minute will be v1, and this velocity is not uniform. Again we are getting 30 by 20, 30 by 20 and 30 by 20. So v2 will be the second uniform velocity. So v1 is equal to 1 kilometer per minute, that is 60 kilometer per hour. If we convert minute into hour, then we will get this. Then 30 by 20 kilometer per minute is the second velocity, uniform velocity, so 90 kilometer per hour. In the second question they ask, when did the bus change its speed? So the bus changes its speed when in the 40 to 60 time period. So 50 minutes is the answer. In the C, what is the distance covered in first hour? So first hour the distance covered is so this is the first hour. So total distance covered is 65 meter. In the D, what is the distance covered in the second hour? So second hour is from 60 to 120, and 155 is the total distance. So we will subtract 65 from 155, so we'll get 90 kilometer in the next 1 hour. Now what is the average speed for the complete journey? Average speed is equal to total distance by total time. So total distance is 155 kilometer and total time is 2 hour. So 120 divided by 60, so 77.5 kilometer per hour is the average speed. In the 10th question, a bicycle increases its velocity from 10 km per hour to 15 km per hour in 6 seconds. Calculate the acceleration. Acceleration is equal to change in velocity divided by time. So change in velocity is 15 km per hour minus 10 km per hour and time is 6 seconds. So we convert the time into hours. So we divide it by 36, 60 into 60. When we solve, we get 3000 km per hour square as the acceleration of the bicycle. In 11th question, an object move along a straight line with an acceleration 2 meter per second square. If its initial speed is 10 meter per second, what will be the speed after 5 seconds later? So initial velocity is 10 meter per second and v, they want us to calculate the v. Acceleration is 2 meter per second square. Time is 5 seconds later. So we will use Newton's first equation. V is equal to u plus at. So 10 initial velocity, acceleration is 2, time is 5. We get 20 meter per second as the final velocity. Now 12th question, an object dropped from a cliff falls with a constant acceleration 10 meter per second square. Find its speed 2 seconds after it was dropped. So dropped, so initial velocity is 0, acceleration given is 10 meter per second square. They want us to calculate the final velocity after time t is equal to 2 seconds. So again we use Newton's first equation. V is equal to u plus at. U is 0, a is 10 and t is 2. 20 meter per second is the answer. Now in 13th question, a bullet hits a wall with a velocity 20 meter per second and penetrates it up to a distance of 5 centimeter. Find the deceleration of the bullet in the wall. So initial velocity is 20 meter per second and it penetrates to a distance 5 centimeter. After that, the final velocity of the object will be 0 and distance is 5 centimeter. So they want us to calculate the acceleration, negative acceleration. So we use Newton's third equation. V square is equal to u square plus 2at, and we are using negative sign because deceleration. V final velocity is 0, initial velocity is 20 chi square minus 2as is 5 centimeters, so we convert it into the meter, so divide by 500. When we solve, we get acceleration is equal to 4000 meter per second square. In 14th question, a train start from a station and move with a constant acceleration for 2 minutes. If it covers a distance of 400 meter in this time period, find the acceleration. So initial start from a station. So initial velocity is 0, u is 0, time is 2 minutes and distance covered is 400 meter. So s is 400. So use Newton's second equation. S is equal to ut plus half at square. S is 400, u is 0, half a and t is 2 minutes. So we convert it into second by multiplying 60. So we get acceleration is 1 by 18 meter per second square. In the 15th question, a ship moving with a constant acceleration of 36 km per hour square in a fixed direction speed up from 12 km per hour to 18 km per hour. Find the distance transversed by the ship in this period. So initial velocity is 12 km per hour, speed up to 18 km per hour, acceleration is 36 km per hour square. So we use again Newton's third equation. V square is equal to u square plus 2as and we calculate the distance. V square minus u square divided by 2a. We put all the numbers. Basically it is very easy when we use the a square minus b square formula. So the calculation will be easy. 18 square minus 12, 18 square plus 18 plus 12 and and when we solve we get 2.5 kilometer. In the 16th question, a particle starts from a point with a velocity 6 meter per second and move with an acceleration minus 20 meter per second square. Oh, minus 2 meter per second square. Show that after 6 seconds the particle will be starting point. So initial velocity is 6 meter per second, time is 6 second, and acceleration is minus 2 meter per second square. And they want us to calculate the distance. So we use Newton's second equation, s is equal to ut plus half it square. 6 initial velocity, time is 6 second, minus half, acceleration is 2, but negative sign because they are giving the negative sign. 6 into 6, when we calculate we get 0 distance. So with this acceleration the distance covered is 0. Now 17th question, a particle move with a constant velocity of 5 km per hour for 10 minutes and then deaccelerate at rate 1 km per hour square till it stops. Find the total distance covered by the bicycle. A bicycle move with a constant velocity. Constant velocity is 5 km per hour for the 10 minutes. Okay, so 5 km per hour for the 10 minutes. So velocity is constant for 10 minutes, and after that deaccelerated, and the velocity now um, going to be 0. So find the total distance covered by the bicycle. So if we want to calculate the total distance, first we will calculate the distance covered by this square, and then we calculate the distance covered by this triangle. So distance s1 is equal to constant velocity into time, 5 multiplied by 10, and we convert the minute into hour, so 5 by 6 kilometer. And for the s2, because g acceleration is there, so we use Newton's third equation, v square is equal to u square minus 2as. We know v final velocity is 0 because they mentioned that till it stops, so v is 0. U initial velocity is equal to 5 km per hour, and s2 we want to calculate, that is 25 by 2 kilometer. So the total distance is 5 by 6 plus 25 by 2 and 40 by 3 kilometer is the total distance. Now in 18th question, an object is moving along a straight line with a uniform speed 10 meter per second. Plot a graph showing the distance versus time graph for 0 to 10 minute. Distance versus time graph for 10 second, and the velocity is uniform. So the graph is like that, uniform speed graph. Okay, in 19th question, a particle move along a straight line with a uniform velocity 5 meter per second. Plot the distance time graph for the time period 0 to 5 second. Again distance and time, and the velocity is again uniform, so again distance time graph will be straight line. In 20 question, the driver of a car moving at 36 km per hour applies the brakes to deaccelerate uniformly. The car stop in 10 seconds. Plot the speed time graph for this period. Find the distance traveled by the car during the period of by calculating the area under the graph. So this is initial velocity is 36 km per hour square, final velocity is 0, and the car stop in 10 seconds. So v is equal to u minus at, Newton's first equation. Final velocity is 0, initial velocity is 36 km per hour, acceleration we want to calculate, and time is 10 seconds. So we get a is equal to 36 divided by 10 into 60 into 60. And now we want to calculate the distance. So distance is area under the graph. S is equal to half base into height. Half base is velocity is time, that is 10 second. We divide it by 60 into 60, so we get the time in hours, and height is 36 km per hour, so 36 we convert kilometer into meter. So we get 50 meter, the area covered by this graph. Now in 21 question, a particle move along a straight line with a constant acceleration plus 0.5 meter per second square, and at t equals 0 the x is 0 and the velocity is 0. So plot the velocity time graph and position time graph for t is equal to 0 and t is equal to 5. We are having acceleration, so velocity time graph will be the, because it is a uniform or constant acceleration, so velocity time graph is a straight line, but distance time graph will be like a parabola, is half at square graph. So in 22 question, figure shows the speed time graph of a bus speed and time, in which period the bus is accelerating. So here the bus is accelerating because velocities keep on increasing. In which period of the bus is deaccelerating, because the velocity is going to be 0, so deacceleration is there. What is the distance covered during its acceleration? So they want us to calculate the distance. So it is for the distance we will calculate the area under the graph of this triangle. So okay, so for the acceleration, so first we will calculate the area under the graph for the first half, for the first 0 to 10 seconds. So half base into height, so base is 10 second and height is 40. So 40 is the kilometer per hour. We convert it into minute, so we get 10 by 3 kilometer. Again, because it is a this is a symmetrical graph, so S2 will be equal to 10 by 3 kilometer. Now they want us to calculate the average speed in the entire journey. Average speed, again total distance by total time. Total distance is 10 by 3 kilometer, 10 by 3 kilometer, and total time is 10 minutes plus 20 minutes. So 10 minutes plus 10 minutes, that is 20 minutes. We convert it into hour, so we get 20 kilometer per hour as the average speed. In the 23rd question, the velocity time graph of a particle moving along the straight line is given in the graph. If is the particle moving in the positive direction at t is equal to 0, does the particle ever come to rest? Or if so, when c does not the particle turn around? If so, when? So the first is the particle moving in the positive direction? No. So no. And does the particle ever come to rest? Velocity is 0. Yes. At t is equal to 0, the velocity is 0, so particle is at rest in this time. Does the particle turn around? If so, when? Yes, the particle is turned around at t is equal to 0, because from negative velocity the positive velocity is started. So that's it for this video. We solved the numerical problems. We completed the numerical problems of chapter 2. In the next video, we will solve the third chapter. Thank you.